Who can represent high-end manufacturing and who is playing the third role? It can be said that in the camera world, it is a fresh breeze whose daily task is to produce lenses for others. Even though they also produce cameras, their sales never surpass competitors. Yes, this is Sigma. For many years, it is ranked first in the industry, and Tamron and Sony are among the world's top 3 supporting players. Sigma is a magical existence. It also makes cameras, yet it has never entered the global top 10. However, the lenses as supporting products lead the market annually. For example, in front of us is a full-frame 4K camera. After the body is formed, the second part to install is the image sensor, also called the photosensitive element. You can simply understand it as a device that converts optical images into electronic signals. First, cover it with an external shell. Then use an electric screwdriver to tighten 4 screws one by one. The mirrorless sensor is not as large as imagined. If you place it in your palm, it's about half a hand. After bonding the flexible cable and coating, place it on the left side of the camera, slightly below the ICE frame by about 5 millimeters. The extra space is just enough for installing the mainboard. Unlike Canon or Nikon, Sigma's mainboards are handmade, so both production capacity and output cannot match the first 2 brands. To reduce dust and dirt, apply a layer of UV sealing glue around it. This is a type of sealing glue slightly lower in technical composition than UV curable glue. If you have related experience, you should understand its effectiveness. Next, carefully attach the screen on top. The tight spacing provides a compact space for the camera. Screws are the final reinforcement for the mirrorless camera. Once tightened, the last step is installing the battery cover. Its role is unusual. Workers rarely use 6 screws on it. The anti-slip pad protects the camera exterior. Before installation, first add double-sided tape in the middle. Then stick the tape along the top. Ensure there's no extra layer and no trimming issues. We see the camera image, but the true technical content lies in the lens magic. Meanwhile, another workshop is intensively grinding glass. This is a key step in camera production. Initially, the glass is not smooth, with countless scratches on the surface. A frosted coating, less than 1 millimeter thick, is applied. To clean it, first machine grind for 20 minutes, then manually float the glass on the platform. Careful observation shows the glass is nearly like ordinary glass. But to reach usable condition, it takes at least 30 minutes. This is a 70 to 200 millimeter telephoto zoom lens, so its size is not small. After cleaning and checking for Newton rings, the glass undergoes more than 5 rounds of spherical measurement both manually and with equipment. Next comes the coating process. Small circular glasses are installed in iron rings. Each groove holds 1 piece, usually 100 per board. Coating involves evaporating compounds at high temperature to adhere to the glass surface. First, it improves light transmission. Second, it enhances image quality and reduces glare and blur. Third, it strengthens reflectivity to ensure light reflects outward. Fourth, it protects the surface from external interference. Early coatings were almost completely controlled by Germany and Japan. Next, glue 2 convex and concave lenses together. This corrects chromatic aberration. Ordinary 2 pieces of glass cannot transmit light so well. A special adhesive is applied between the 2 pieces. You can even see similar techniques on high-end phone lenses. Then, place the lens glass on a rotating platform. Apply black paint to the outer ring. Besides absorbing light, paint reduces reflection to some extent. Every corner must be perfectly aligned. Once formed, use suction cups to place it on the platform. Reinforce the lens one-on-one, manually. There is no assembly line. Each worker prepares to install glass into the frame. Locally, it is called the lens stone, the closest glass to the camera. It must not only be pressed in, but also be sealed with UV glue around the gap. Once the sealing reaches the standard, place it in a small box next door. When tightened, purple light emits inside, the commonly known UV irradiation. UV curing is widely used in lithography. Each piece is handcrafted manually. Nearby, another workshop produces the lens housing, also called the lens barrel. The main body is made by sawing a tin solder mixture. Both the lens barrel and the front cap are plastic extruded. Plastic is resistant to heat and corrosion. For example,